Hi guys, my name is Terry. In this video, I'm going to go through with you Form 4 Additional Mathematics textbook question for Chapter 1 Intensive Practice 1.2. If you enjoyed this video, kindly like, subscribe, or leave us a comment. Now let's get straight to the first question. So here we have two functions defined as fx equals to 2x minus 1 and gx equals to x over x plus 1. So the first part, what we want to do is we want to find f(gx). Now f(gx) simply means we put function gx inside fx. Your function gx in this case is x over x plus 1. Now remember, if I write fx equals to 2x minus 1, if this is x, this will be x, right? So if you put a number like 1, this will be 1. If you put, for example, 1 over x, this will be 1 over x. And in this case, what are we doing is we're putting in x over x plus 1. So I need to replace this with x over x plus 1. So here we can rewrite this as 2x over x plus 1 minus 1. Now let us simplify this expression. Now, in order to combine this as a single fraction, we have to multiply top and bottom here by x plus 1. So what we have instead is 2x minus, there's a negative here, so I'm just going to multiply the negative 1 inside, so it's going to be minus x minus 1 over x plus 1. So your end result will be x minus 1 over x plus 1. Now remember, every time you have a function involving with denominator involving x, we have to write here x cannot be negative 1. Why? Because a function becomes undefined if you have, let's say, 1 over 0. 1 over 0 is undefined, or we say infinity. So if your denominator is 0, in this case your denominator is x plus 1, we let it be 0, your x is negative 1. If you put negative 1 inside here, what you will get is, for example, minus 1 over minus 1 plus 1, you get minus 2 over 0, so the whole thing becomes undefined. So here we have to state what are the values of x for which the function is invalid. So we write here, you can take any x value except negative 1. Okay, that is your f(gx). So how about your g(f(x)). Okay, let me move this up a bit. To find g(f(x), we are now putting fx inside gx. My fx is 2x minus 1, and my gx is x over x plus 1. Again, when it comes to composite function, you got to think in terms of bracket. So we're going to put inside a bracket here 2x minus 1. So this is 2x minus 1, and I'm going to put in 2x minus 1 here as well. So your outcome will be 2x minus 1 over 2x minus 1 plus 1, which gives us 2x minus 1 over 2x. And here we write x cannot be 0. Again, why? You don't want your denominator to be 0. If your denominator is 0, the whole function becomes undefined. Okay, moving on to part B. So in part B, we're finding fg2. Now since we already know fgx, so I'm going to replace x with 2. So this will be 2 over 2 minus 1 over 2 plus 1, which is going to give us 1 over 3. Yeah, guys, I'm going to put in 2 inside the x here. So take note. Okay. Next, how about gf negative 1 over 2? So I'm going to put negative 1 over 2 inside my gf. My gf is this. So just use the result. It's going to be 2 negative 1 over 2 minus 1 over 2 negative 1 over 2. Okay, in this case, 2 times negative half is negative 1. Negative 1 minus 1 is minus 2. You divide by another minus 1. Your answer is just 2. Okay, next, find the value of x when fgx equals to gfx. Now we know fgx from the first part. Yeah, my fgx is x minus 1 over x plus 1. My gfx is 2x minus 1 over 2x. Yeah, from here, from part A that we got earlier. Now, the next thing is to solve for x, we have to cross multiply. So I'm going to take 2x, multiply with x minus 1, and the x plus 1 here, I'm going to multiply with 2x minus 1. Let us expand the bracket. 2x squared minus 2x is now 2x squared minus x plus 2x minus 1. I hope you know how to expand one by one. 1, 2, 3, 4. Alright, and from here we will get 2x squared plus x minus 1. So the good news is, you notice you can cancel the 2x squared here. Yep. And you're left with minus 2x on the left and an x minus 1 on the right. Now it's up to you. You want to bring this over. Maybe it's easier just bring this over. This minus 3x equals minus 1. Just divide them. Yeah, x is 1 over 3. Okay, so that is question number 1. Okay, let's move on to question number 2. Okay, in question number 2, we have function f and g. They are defined by fx equals to x over x minus 1 and gx is hx plus k. So you're given g3 is 8. So maybe we start off by using this. G3 equals to 8. G3 equals 8. That means we put 3 inside your g here. So it's going to look like this. H times 3 plus k. The result is 8. So we can write 3h plus k equals 8, and we call this equation 1. So the second thing is you're given gf3. gf2 means we put 2 inside your f, right? Okay, maybe I write this one by 1. Gf2 is 5. I put 2 inside my f, so it's going to look like this: 2 over 2 minus 1. I'm putting inside f here. The result is now 5. So this is g2 equals to 5. Okay, now we know g2 means we put 2 inside the g here, so it's h times 2 plus k. The result is 5. So answer 2h plus k equals to 5. So what we have here is a pair of simultaneous linear equation with unknown h and k. So as you have learned this in Form 1, we know that to solve this we can either use elimination or substitution. For me, when it's arranged in this form, it's actually easier to use elimination. And after all, they have the same coefficient of k. Can you see? 1k, 1k. So I'm just going to take equation 1 minus equation 2. So that 3h minus 2h, you get a h. K minus k disappear. 8 minus 5 is just 3. And then we sub inside any equation we do. I'll take equation 2. 2h is 3 plus k equals to 5. This is 6, right? So you bring over 5 minus 6. K is negative 1. Alright, yeah, not too difficult, but A. Next one. Find the value of A if FGA is now 3. Now that we know Gx is H, which is 3, x plus k, k is negative 1. So FGA means we are going to put A inside your G. So it looks like this: 3A minus 1. Instead of writing Gx, we write G8. So it's 3A minus 1. Now take this and put inside your F. Remember, fx is x. Okay, let me write nicely. X over x minus 1. If you put 3a minus 1 here, we need to replace it with 3a minus 1. Now your FGA is now 3. So this is 3a minus 1 and this is 3a minus 2. So what we need to do is to cross over, multiply over to get 9a minus 6 equals 3a minus 1. 9a minus 3a is 6a. Bring the 6 over, you get 5. A is 5 over 6. Alright, that is question number 2. Okay, let's move on. Question number 3. So function f and g are defined by fx equals to ax minus b and gx is x plus 4. So it's rather similar to the question just now, number 2. So we have to use these two information here. We start off with fg2 equals to 9, yeah, to form the first equation. Gf half equals to 2. to form the second equation, and we solve them simultaneously. So let's start with fg2 equals to 9. So I'm going to put 2 inside my g, so it's going to look like this. f2 plus 4 equals to 9. f6 is 9. Put 6 inside f. 6a minus b equals to 9. This is my first equation. Okay, so by the way, guys, I just so you know, sometimes I write a times 6 minus b. We can do that, but I thought we can straight write 6a. Yeah, don't need to write a times 6, because a times 6 is actually 6a, right? So the second one, we will have g f half equals to 2. So we're going to start by putting half inside your f. So it's going to look like this. G a times half, I'm going to write half a minus b. The result is now 2. So take this and put inside your g. Your g is x plus 4. G bracket will be bracket plus 4. You let it be 2. So this is half a minus b equals to, I bring the 4 over negative 2. Now, although I know a lot of people don't like fraction, you can choose to multiply by 2. But I look at it that my coefficient of b is negative 1 each. So it's easier to just eliminate straight away. That is, we take equation 1, we minus equation 2 straight away. It's just that we have to deal with fraction. But it's not too difficult, right? I hope so. It's 6a minus half a, 9 minus minus 2. Let me just write down one extra step so you can understand that. 9 minus minus 2. 6a minus half a is 5 and a half, so we can write 11 2. 9 minus minus 2 is 9 plus 2, which is 11. A is just 2. So once you got the value of a, we can just sub inside any equation. Maybe I sub inside equation number 1. So 6 times 2 minus b equals to 9. 12 minus b is 9. b is 12 minus 9. Yeah, b is just 3. Okay? That is question number 3. Alright, so let's move on to question number 4. In question 4, function f and g, they are defined by fx equals to 2 over x minus 3, where x not 3, and gx is hx squared plus k. Now again, they are quite similar to question 2 and 3. So the first part is we want to use this information. G2 is 5, so that means we're going to put 2 inside your g. So it's going to be, okay, let me rewrite here. G2 equals 5, so it's going to be h2 squared plus k equals to 5. So 4h plus k equals to 5, first equation. The second equation is gf1 equals to negative 1. That means we put 1 inside your function f. So this will give us g negative 1 equals negative 1, right? So as we put negative 1 inside here, so it's h negative 1 squared plus k equals to minus 1. So negative 1, when you square it, it's still 1. So h plus k is minus 1. Second equation. Okay, again, I like to solve them using elimination because I can see they have the same coefficient of k, which is 1. So I'll just minus equation 1 minus equation 2. 4h minus 1h is 3h. 5 minus minus 1 is now 6. h is now 6 divided by 3, which is 2. Okay, I still need to find k, so I have to sub inside equation number 2. 2 plus k is negative 1, k is negative 3. My part A is done. Let's move on to part B. Find the expression for g f. Okay, I know my h and k already, so maybe I rewrite here gx is now h is 2, x squared, k is negative 3. So now I'm going to put fx inside gx. We know gfx means putting fx inside gx. My fx is 2 over x minus 3. My gx is 2 bracket square minus 3. So the bracket I have to put 2 with the x minus 3 squared. Now the thing is that normally if you expand the denominator, there's nothing much we can do. We cannot plus and minus the denominator. So I'm going to keep my denominator as it is. Okay, so I'm just going to square the top. So 2 squared is 4. This is x minus 3 square, right? I write one extra step for you. Okay, now, but we can combine this as a single fraction. So what we need to do for the 3 here is to multiply top and bottom with x minus 3 squared, so that I can combine them as a single fraction. So when I do that, the 2 and 4 times together becomes 8. And I'm going to expand this straight away. The x minus 3, when you square it, is x squared minus 6x plus 9. And let's keep our denominator as x minus 3 squared. There's no harm expanding the denominator, but there's no point doing so, right? So we can't simplify with anything. So let's just simplify the numerator. Expand this 3x squared plus 18x minus 27 over x minus 3 squared. As I put everything together, is minus 3x squared plus 18x minus 19 divided by x minus 3 squared. Okay, that's your answer for part B. Okay, moving on to question number 5. Okay, so this is the case where you have to use what we call iterated function or repeated function. That means we have to put fx inside fx 3 times. There's f3x. Okay, now f3x, as I say, is putting fx inside fx. Now I'm given fx, but it's in terms of unknown a, b, and x. So we write ax plus b the first time. Okay, so we gotta be careful with this. Fx is ax plus b. So you think bracket. If I put ax plus b inside this bracket, I need to put ax plus b inside this bracket as well. So it's going to look like this, a with the ax plus b plus b. Okay, if you find this a bit confusing, please write it down like this, yeah, easier to understand. So let's expand this further. This is a squared x plus ab plus b. Now again, this time I'm going to keep this bracket empty like this. Now I need you to think, this is very long, a squared x plus ab plus b, a squared x plus ab plus b. You're going to squeeze the whole expression inside your ax plus b. So I'm going to write here a of a squared x plus ab plus b with a plus b outside. So let's expand this further. You will get a times a squared is a cubed x. There's a squared b. There's a ab and another b. Now notice that this expression is in terms of a single x, right, and a constant. So what we want to do is we want to compare this with the given function fx above, f3x, right? So when I say compare, we need to compare the term with x with the term with x, and then we need to compare the constant with the constant. Constant means the one without any x. So maybe I write here, by comparison, when you compare your a cube is now 27, cube root of 27 is just 3. Okay, the next one, your a is now 3. If I put this inside, a squared is now 9 plus a is 3 times b. There's another b here, add them together, the result is 13. So what we have here is 13b equals to 13, b is just 1. Okay, so I've got my values of a and b. The last thing is to find f for x. Now what is f for x? F for x means f3x. So since I already have my f3x, okay, my f3x is 27x plus 13, and I also know my fx already. Okay, let me just revise my fx. I know that my fx, my a, is now 3, my b is now 1, so it's 3x plus 1. So what we're going to do here is to put this inside 3 of a bracket plus 1, which is 27x plus 13 with a bracket plus 1. So expand 81x, 3 times 13 is 39, plus 1, answer 81x plus 40. Alright, that is question number 5. Okay, let's move on to question number 6. Okay, in question number 6, diagram shows a tissue box with a square base of side x, height of 10. So write the base area of the box as a function of x and the volume as a function of a. Okay, we know that if you have a base x, a square base x, length of side x. So your area here is just a function of x is just x squared. Simple, right? Now we also know that when you have a prism, prism can be a cuboid. Cuboid is a prism. If you have a prism with a cross-section area of A and you have height of h, the volume V is just AH. So we can say the volume VA is a function of A, right? So volume is just AH. Um, but my H is given as 10. So maybe I just replace this as 10. Or you can write times 10, which is just 10A. Okay? So this is individual function at A in terms of x and V in terms of A, volume in terms of the cross-section area. Alright, now then they say show that the volume V is a result of composition of these two functions. So basically what we want to do is we want to form a composite function relating A and V. So we know the composite function VA, we can write this as VAX, yeah, is basically putting AX, which is x squared, inside your V, right? And then I'm going to put this inside V, so what do you get? 10 times x squared. So we have shown that A, volume, is a result of composite function of VA. Okay, that is number 6. Okay, let's move on to number 7. Now, number 7 is probably the more difficult one because you're finding the function inside given the function outside and so forth, right? So normally in a composite function, you will be given like fx and gx, and then you're supposed to find gfx, right? So when I say function inside, I'm referring to function that happens first, right? The function on the right. So sometimes you're given fx, gfx, find gx, or you might be given gx, gfx, but you're supposed to find fx, the other way around. So for both of this method, what is given, what is not, right? So the method of solving is we always let the function inside becomes y. Now when I say function inside, I'm referring to the function on the right, the function that happens first. So we let gx becomes y. Why? Kenapa? Because we want to reduce this from two function to a single function. Now see, your function fg, we can write like this. This is your fgx. It is now 2x squared minus 3x minus 4 minus 7. My gx is now y. We'll replace it with y. Okay. What are we finding? We're finding function f. You're finding function function g. Sorry, you're finding function g. Your given function f. Your fx is x plus 6. So fy will be y plus 6. Can you see that? Fx is x plus 6. Fy is just y plus 6. So our job is to find gx, which is y. I'm finding y. So let's make y as a subject. So it's 2x squared minus 3x minus 11. So, sorry, minus 13. 7, 6, 13. Therefore, your gx is 2x squared 3x minus 13. Alright, that is part A. I hope this is not too difficult. Part B, again, we let the function inside equals y. Now, in this case, the function inside is fx. Okay, so when you let fx becomes y, so let me rewrite gfx is now x squared plus 4. This is gy is now x squared plus 4. The thing is, now I'm finding function g, right? To find function gx, I must first find function gy. To find gy, I must change all the x into y. So the question is, how do you do that? Okay, you go back to your function fx. We know fx. And we know fx is now x plus 6. And the result is y. If you want to change all the x into y, you need to make x as a subject. So x is now y minus 6. Okay, y minus 6. And I'm going to take this and sub inside here. So my gy is y minus 6 squared plus 4. So when you expand this, you should get y squared minus 12y plus 36 plus 4. That will give us y squared minus 12y plus 40. Therefore, gx is x squared minus 12x plus 4b. All right. Next, part C. Now part C is very similar to part B. Again, we let fx equals to y. Why? We are finding g. We want to reduce this from two function to one. When you reduce it to one function, you can see clearly I can find gx first. But before you find gx, I need to find gy. To find gy, I must change all the x into y. So what is the relationship between x and y? We go back to your fx. Your fx is x plus 6 and is now y. Let's make x as a subject and sub it in. Gy is 8 minus y minus 6. So when you expand the bracket, you should get 8 minus y plus 6, which gives us 14 minus y. So therefore gx is 14 minus x. Yep, that is your number 7. Okay, let's move on to number 8. Okay, for question number 8, if you look at the diagram, it looks a bit hard to comprehend. So what I would suggest is that you redraw this. Maybe I draw in this direction. It's easier for most people. Yeah, you're more familiar with this diagram, right? Okay, let me just adjust a little bit. Okay, so now we know that if I start off with function p, I map onto q, q will map onto r. Now p can go directly to r using the function g fgx, and this is x squared minus 3x plus 6. Okay, so what we want to do is we want to write the function that map p to q. P to q, when we say fgx, it means g happens first, followed by f. So the function that map p to q is basically function gx. But we want to write in function notation, you can write g dot dot x arrow x minus 1 over 3. It is given here. Yeah, p is mapped onto q using this function. Okay, next, find function that map q to r. So to find q to r, we know is function fx. So for question number 7, we've done a number of questions related to this. So we are going to let gx becomes y. So go back to your fgx. It is x squared minus 3x plus 6. By letting gx becomes y, this is now fy, and fy is x squared minus 3x plus 6. Now, what are we finding? We're finding function f. To find function f, we must first find fy, right? To find fy, I must change all the x here into y. So the question is, what is the relationship between x and y? We go back to your gx. Your gx is x minus 1 over 3 and is now equals to y from here, right? So what we're going to do is we make x as a subject. X is 3y plus 1. Now let's take this and substitute inside your f. So when I sub inside, this will be fy is now 3y plus 1 square minus 3 with the 3y plus 1 plus 6. Let us expand the bracket. You get 9y square 6y plus 1. This is going to give us 9y minus 3 plus 6. Simplify for the 9y squared. The 6y you minus 9y, you get minus 3y. And 1 plus 1 minus 3 is minus 2 plus 6. You're left with just 4. Now if fy is 9y squared minus 3x, fx is therefore 9x squared minus 3x plus 4. Just rewrite them. Okay. Alright. Let's move on to the last question, number 9. Okay. Alright. So for question number 9, you're given function fx. So fx is now px plus q, and f3x is 8x minus 7. No, we've done something like this earlier, right? So basically what we have to do is to find f3x by putting fx inside fx 3 times. Okay, so you want to start off by putting the px plus q inside. So this is px plus q, and we put px plus q inside your px plus q. So I'm going to cut short my explanation because we have done something like this earlier, so you can refer back to the previous question. So it's going to be px plus q. Sorry, there is an extra p here, right? So p of px plus q plus q. So let's expand this bracket. So it's going to be p square x plus pq plus q. We put it again inside p of p square x plus pq plus q with a plus q. So this is going to give us p power 3x plus p power 2q plus pq plus q. Now you're going to take your f3x, yeah, 8x minus 7 and compare. So again, by comparison, when we compare p power 3 with 8, and then we compare this whole thing with negative 7. Negative 7, the negative is there. So now, by comparison, I can see that p power 3 is 8, p is now 2. So put 2 inside your p, 2 square is 4, 4p plus 2q, sorry, 4q. Sounds like a bad word. 4q plus 2q plus q equals negative 7. So I've got 7q equals negative 7. Q is minus 1. Alright, yeah, it's very long. Okay, then they say determine the function f4. Now we know f4, in fact we've done something like this before, is basically f3, right? And we already know our f3. My f3 is 8x minus 7. My fx, now that I know p, p is 2, q is minus 1, is going to give us 2 of 8x minus 7 minus 1. So when you expand this, you should get 16x minus 14 minus 1, which is 16x minus 15, right? Now, the next part is we want to identify the pattern. They say by studying the pattern of f, f2, f3, f4, determine the general rule for f and x. So I'm going to list down for you. We know f1 is now 2x minus 1. And we know our f2 is, okay, I think we define f2 first. So fx, okay, in fact, I think we can cut short our working. This is my f2. Let me highlight for you. This is my f2, correct? Isn't this f2? So you can actually cut short your working. Don't have to do so long. We already know p and q, right? So I'm gonna put in here my p is 2. I square it. Another 2. Q is negative 1. Negative 1. So this is 4x minus 3. This is my f2. Now I need to see a pattern here. Okay. Maybe I'll leave it some space. Let's do our f3. We know my f3, right? My f3 is 8x minus 7. And let's look at our f4. My f4 is 16x minus 15. So the first thing you need to see is look at the power for f. For coefficient of x is 2 power 1. Look at this. This is 2 power 2, which is 4. This is 2 power 3, which is 8. This is 2 power 4, which is 16. Now you might want to write like this. 2 power 1, 2 power 2, right? And this is 2 power 3. This will be 2 power 4, right? So the next thing is, let us look at the constant. Now I know when you look at the constant, it's a bit hard for a lot of people to see. If you were to look at it from here, it's a bit hard to see. A bit hard to see a pattern. So I need you to look across, as in, what is the difference between? Let's look at the difference between these two numbers, this one and this one. Minus 1, right? This one and this one. Minus 1. This and this. 8 to 7 minus 1. 16 to 15 minus 1. So we just have to minus 1, right? So now we need to think this is now, okay, let me write here 2 power 2 minus 1. This is now, but there's a negative here, there's a negative in front, so I'm just going to leave a negative here. Okay, there's a negative here. This is going to be 2 power 3 minus 1. This is going to be 2 power 4 minus 1. So your f and x is now 2 power n with the 2 power n minus 1. But remember there's a negative outside, yeah? Okay, I hope this is not too difficult, right? So yeah, hope you have learned something from this video, right? Thank you for watching. Oh, I still got one more to go, right? Sorry, there's one more to go. Okay, a car manufacturing factory manufacture N car daily af- after T hours operations given by this NT and the cost of manufacturing X car. So this one's supposed to be X, not N, X. So find the cost C as a function of time. Okay, very simple. I know the function for number of cars manufactured in terms of what do you call that? Time. C is the cost, right? So if you want to find C and T, we basically put N inside C. N is 100T minus 5T squared, right? And your C is 15,000 plus 8,000 x. My x is 100T minus 5T squared. So when you expand the bracket, you get 15,000 plus 800,000 T. 8,000 times 5 is 40,000 T squared. Okay, that's all for the last question. All right, so thank you for watching. I hope you learned something from this recording. If you uh, wish to get more workbook, you can actually find out from us. Yeah, visit our Shopee site, right, or contact us. Thank you very much.